So in this video, we're going to be looking at a separable differential equation, and this is the equation. So we have to find the solution for this equation, this differential equation. So what we can start off doing is isolating the dy over dx. So we just subtract 2xy squared from both sides, and we're left with this. Dy over dx equals the subtracted 2xy squared. And here, it may look a little complicated, but it's not too complicated because all I'm doing here is I'm multiplying dx by both sides, so we'll get rid of the dx here, and we'll be left with dy. And on this side, so right here, we're just getting rid of the dx, we're left with dy, and I'll tell you where this came from. You subtract y squared from both sides. We'll get the y's on one side, and the x's on the other side, and you might be wondering, why is it 1 over y squared? And that's because instead of writing dy over y squared, I just took it out as 1 over y squared. So if you multiply dy times 1 over y squared, you'll get the same thing. You'll just get dy over y squared. But I just took it out. It's easier to work with and simplify. So after we cancel dx, and on this side multiply dx because we multiplied it here, then divide y here, and we're left with this here. Our final equation, I crossed this out because I miswrote something, but we'll get dy times 1 over y squared, which is just dy over y squared like you would expect if you were to divide. And on the right hand side, we'll get 2x times dx. We multiply dx by both sides, divide. Okay, so I hope you understand where I'm getting these from. So now we can take the integral of this to solve this equation. So we take the integral of the left side and the right side. And what we could do here on the left side is just bring the y to the numerator, and we'll get a negative exponent, but it'll be easier to work with. And here it's just because there's an invisible one here, you add 1, then divide by 2, and negative 2 divided by 2 is just negative 1, so you'll be left with negative x to the exponent of 2. Remember, you added 1 to the exponent of 1 that was already there. And then plus c1, which is a constant. And here you get, so negative 2 plus 1 will get negative 1, divide by negative 1, you'll just get negative y to the negative 1. And here's our integrated form so far, but it's not complete. We can simplify much further. And so we can bring y to the bottom here, and we'll get a positive numerator of 1, so we don't have to write it. And we'll get 1 over y, and this is a negative fraction because of the negative here. So negative 1 over y is equal to negative x squared plus c1. So a cool trick you can do here is we want what y is equal to. So instead of leaving this as a reciprocal, we can just take the reciprocal of the whole thing. So if we flip the right side, this side gets flipped too, right? So y would equal 1 over x squared minus c1 because we flipped the right side. And then we're just left with y is equal to this. This gets flipped, we get rid of the fraction, we get a clean y on this side, but this gets flipped too. But this is our answer, so we're fine. And one little thing you could do here is, because I wrote c1, you could just define that c1 is equal to c, and then your final solution will be y is equal to 1 over x squared minus c1. And yeah, you're good.